So make a start with the second half. As usual, our president has hightailed it back to Manchester, so you're left with me in charge of you. And I'm going to do a very brief what's coming on in the sky in the next 3 months. So let's bring the lights down and let's talk about one or two things. Now, the obvious thing to talk about is the transit of Mercury, due on May the 9th this year, and just in a couple of weeks' time. Wednesday, May the 9th. Is it Monday or Wednesday? I can't remember. Thank you. Way ahead of me. This, of course, is a simulated view. This is not the real thing because, well, there's a couple of sunspots. There's very few sunspots on the sun at the moment. And Mercury will be going across the sun in that direction as seen in the sky. And it starts at about 11:45 in the morning and finishes about 7:45 in the afternoon, in the evening. And it's a long time since we've seen one going that's so centrally across the disk. It's not quite central, it's about a third of the way down. Now, rather than do all the chat myself, having just recorded in the last couple of months a video with Lucy Green, I thought I would cop out by showing you that instead. So for the next few minutes, we'll let Lucy do the talking.
On May the 9th, 2016, a rare spectacle will be seen across the British Isles and most of the Western Hemisphere, a transit of Mercury. Now, Mercury is the smallest planet in the solar system, but also the closest planet to the Sun, and that makes it very tricky to spot normally. But during its transit, you'll be able to see it as a black dot moving slowly across the face of the Sun. Mercury passes between us and the Sun every 16 weeks or so, but more often than not, the planet either passes above the Sun or below the Sun, so we don't see it directly. And that's because Mercury's orbit is tilted compared to the Earth's, so we only see it crossing the face of the Sun every so often. In fact, this century, there are only 14 transits. So how do you view the transit? Well, you can't look at the Sun directly because it's so blindingly bright, and even if you have eclipse glasses left over from a previous solar eclipse, they won't work. They will block out the light from the Sun, but unfortunately Mercury is just too small to be seen, so you'll need a way of magnifying the view so that you can pick out the disk of Mercury in front of the Sun. The best way to view the transit of Mercury is by using a telescope, because then you can magnify the view. But remember never to look down the telescope directly unless you have a solar filter on the front end. Now, if you're wondering where you can get that kind of filter, well, in fact, you can make one yourself by purchasing some Barda filter, which you can just get on the internet, and you'll see it's a silvery material. Then you can make a cap out of this material that you put on the front end of your telescope. Now, to make it easier, you may have a telescope cap, lens cap, that looks something like this and has a hole in it. And in that case, you can pop the filter on the inside of your cap and then put that on the telescope. And always remember also to put the filter on the front end and not the eyepiece, because you want to block out most of the sun's light from entering the telescope. Once your filter is snugly in place, it's time to start looking at the Sun. But actually finding the Sun isn't as easy as it sounds. Start off with the lowest magnification on your telescope. That's the eyepiece with the largest number on it, say around 25 millimeters. Use the telescope shadow to check when it's pointing at the Sun. Basically, you want to get rid of that shadow. You can then increase the magnification once you've found the Sun by using an eyepiece with a smaller number on it. The other way to observe the Sun and the transit is to project the Sun's image through the telescope. And this idea is very simple. Just point your telescope at the Sun and hold a piece of white card as a screen around 30 centimeters or so behind it. Now, as you can't look through the instrument, you have to use its shadow again to judge when you're lined up. You can get an image of the Sun on the card, which will probably be out of focus to start with. So focus it up and get a sharp-edged image of the Sun on the screen. With the telescope, again, use your lowest magnification eyepiece, such as a 25mm eyepiece. To get a larger image, hold the card further away and refocus. But watch out, because the sun's heat could be focused on the inside of the telescope, so it could start to melt the eyepiece. Now, many eyepieces use plastic interior parts, so keep the sun in the centre of the field of view and for short periods only, so that the sun's light goes through the glass only and so that you don't damage the edge of the eyepiece. If you're using this method, then make sure that nobody can look directly through the telescope when you're not around. And also remember to cover up the finder telescope on the side. Now, the timings. Mercury will appear on the left-hand edge of the sun. Now, many telescopes will reverse the image, so remember that this is the trailing edge of the sun in its movement through the sky. You might not see it immediately, but within a few minutes it should be obvious. Then for around the next 7.5 hours, Mercury moves slowly across the sun's disk. It crosses a third of the way down the disk as seen in the sky, which is the upper edge as seen through most telescopes. Now, because the transit lasts so long, there's a really good chance that you'll get to see at least part of it, even if you don't have perfect weather. But there are also other things that you can look out for on the sun, as well as the black dot of Mercury. Well, there are other black spots on the sun's surface, and these are sunspots. Now, they could be larger or even smaller than Mercury. Now, you'll be able to set them apart from Mercury because they don't move during the 7.5 hours, and also they change in number and size from day to day, so you can even look on the internet to see how the sunspots looked the day before. You'll also probably see that the edge of the sun's disk and all of the other features on it, including Mercury, seem to be rippling. And this is nothing to do with the sun itself, but it's caused by our own atmosphere, which is quite turbulent, especially on a warm, sunny day. So what about the rest of the year? What other astronomical events are coming up? Well, in September, there'll be a solar eclipse, but you won't be able to see that unless you're in Africa or somewhere on the Indian Ocean. In fact, the next solar eclipse visible from the UK won't happen until the 21st of August 2017. So make sure you get out and enjoy the transit of Mercury. Have a party, celebrate the event. I'm Lucy Green and I'm Chief Stargazer at the Society for Popular Astronomy. And if you want support or advice on anything to do with observing, pop over to our website www.popastro.com.
There is also a leaflet on the website which you can download. If you know any schools, people interested in the subject, by all means distribute this leaflet to them. They can print it out, stick it on their walls, whatever, and that gives you all the information that Lucy's told you. Lucy's video is also on the website, and lots more information. Now, okay, I was going to talk about the constellation of Virgo. The Virgo cluster is something we've all heard of, a wonderful collection of galaxies in the sky. And when you look at a star map, or when you look at pictures in the book, it seems to be absolutely crammed with galaxies. And you think, well, how could I ever miss those amazing galaxies? You look at a map of the area of Virgo, and this is just a few of them. Some of the star atlases show literally hundreds of galaxies in that area, all of which are apparently visible with small telescopes. However, you look through your telescope at that part of the sky and you don't see a thing, just one or two stars. The problem is that finding these galaxies is quite tricky because it is a fairly empty part of the sky. Some parts of the sky, like around Cassiopeia or Orion, have got lots of bright stars, and you can use the individual stars to find your way around that part of the sky. But Virgo is actually quite an empty part of the sky. There are very few stars in the centre of the area of Virgo which you can use to find your way, and for years I struggled to find objects in Virgo. Then I found a quick way around Virgo, and I'll show you what it is. First of all, where do you find Virgo? Well, this time of year you have Ursa Major, the plough, pretty high up, more or less overhead. And you follow the handle round and you come to the bright star Arcturus in Bootes. Carry on and you get to the bright star Spica in Virgo. And so here's the constellation of Virgo, and at the moment, it's not on this picture, you've got the planet Jupiter, which is just about there. So Spica, Jupiter, really bright, and this is what they call the bowl of Virgo. and there are just masses of galaxies on maps in that area. But to find them, you need to weigh in. And what I do is go to the star Denebula, which is at the tail end, literally the tail, in fact, of Leo the Lion. Denebula means the tail of the lion. Just as Deneb is the tail of the swan, Deneb, tail. And there's an area here which I'll show you in a moment in more detail. And there's a star just there, which is labelled 6 here, which is called 6 Commi. Coma Berenices is part of the sky. And so you find Deneb, move with your binoculars, which is all you need, just a little way to the east, and you come to this star, 6 Commi. And here it is, there's the nebula, and there's 6. Now, this is roughly the field of view of your average binoculars is about that. So, you can navigate this area quite easily. From 6, you look down to the southeast, and you find a pair of stars called Rho Virginis. I was looking last night, and they really are actually quite easy to find. So 6, Rho Virginis, and in between the two are some of the brightest galaxies in the Virgo cluster. One good guide, I'm going to zoom in on this area now. There's 6, there's Rho. One good guide is this little triangle of stars, a sort of quite a neat little equilateral triangle. They're all about 8th magnitude, so they're visible with 10 by 50 binoculars without too much trouble. And we've had some lovely clear nights, lovely cold, beautifully cold nights recently, haven't we? And that's all because of this north wind, which has been bringing cold, clear, dust-free, moisture-free, pollution-free air down from the North Pole for our delight. And so if that keeps up, you may well be able to find these for yourself. In between those stars, you will find very faintly, but nevertheless there, even with binoculars as small as 10 by 50s, under a good clear sky, you don't have to be literally in Kielder or Galloway or wherever, you will be able to find these in a reasonably good country sky with binoculars. Those two galaxies there, M86 and M84, are the two brightest, along with M87, which is possibly the brightest, but I find those two easier to see. And that little triangle of stars gets you into the right part of the sky. So have a look. Here's a photograph which actually shows you more or less what you would see with binoculars, or this is a more magnified view. And this was just taken with an ordinary DSLR camera. There's that triangle, there's M87, then there's M84, M86, and you can see one or two of the others there as well. When you get the close-up photographs, there's M87, 84, 86, and you can see this lovely chain of galaxies called Markarian's chain, and you see all the spirals, but they're just fun to look for with your binoculars. So that's your project for the spring. Look for the galaxies in Virgo. Also, over the next few months, you will find Saturn and Mars down in the southern sky. This is more or less taken for the middle to the end of June, when the skies are quite light, looking southwards, and you will find that that they form an unusual pattern. We don't normally see planets that far down, so many of them. You will recognise that even if you're not an avid sky watcher, that we don't normally see planets that far down. Unfortunately, being right down in Scorpius, they are a pig to observe, because the definition of the atmosphere is really poor down there. You're looking at them through huge layers of atmosphere, so not very useful at all. One thing to note is that the star Antares there, which is a red giant star in Scorpius, you can see the pattern of Scorpius there, and the sting of Scorpius disappears below the horizon. We don't see it from these latitudes. But the word Antares means the rival of Mars, Ares, the opposite of Ares meaning Mars in Latin, and there's Mars itself. You can compare the colour. The reason is that Mars, actually a lot brighter than Antares, is actually, they're both red colours, so that's why how Antares gets its name. So you can watch the movement of the planets. Here's a shot that I took literally last night, or this morning actually, to be honest, about half past 1 or 2 o'clock this morning. There's Mars. It was redder in the sky than I actually was able to photograph it. That's a bit sort of overexposed to show all the stars. But there's Mars, there's Antares, and they're quite close together, Saturn and Mars. That's Saturn, there's Mars at the moment. So those are things to look out for in the sky over the next few months. So I shall move on from there. Oh yes, Mars' opposition, 22nd of May, just in about 3 weeks' time, and that's when it will be at its closest. You can look at it through your telescopes. You won't see much, although it's at opposition. I forget the opposition diameter. Anyone? About 15 arc seconds, something like 18, I think. 18 is it? Thank you. Normally that would be a wonderful opposition to look for, but very few photographs have been sent round from the northern hemisphere. Some lovely ones from the southern hemisphere, where it's way up there, but from the northern hemisphere, not so good. Similarly with Saturn, at least you can say you've seen the planets, but I wouldn't expect to see very much on them. But Mars, on the 22nd of May, it's at its closest pretty well, and Saturn on the 3rd of June. So those are the times when we will get the closest views of them.